Hi there. Now here we've got a question based on velocity and acceleration vectors. So if you'd like to have a go at it and haven't had a chance to read it, I'll just give you a moment to pause the video, and when you come back I'll take you slowly through the work solution so you can check your methods against mine. Okay, welcome back then. Let's see how you got on. Now for part A, what we use is the fact that the force is equal to mass times acceleration. We're dealing with vectors, so it's the vector F equals the mass times the vector for acceleration. And I should be able to find out what the vector for acceleration is and then go on to work out its magnitude and show that it's 2 root 13. So working from this, we've got that then for F, it's going to be 3i minus 2j. I'll just underline those vectors, is equal to the mass, which is 0.5, times the acceleration vector, which is a. So if I was to multiply through by 2, then we would get 6i minus 4j is equal to the acceleration vector a. And I've got to get that magnitude of this vector. So assuming that I was a unit vector in that direction and j was a unit vector upwards, then this vector for a would be 6 units across. Let's just mark that in as 6 units across, something like that, and 4 units down. So if we mark those on, you're going to have a vector like that for A. Okay, six units across there, 4 units down. And to get that magnitude, all I've got to do is just simply use Pythagoras Theorem. So therefore, what we've got is the magnitude of the vector A is going to be equal to the square root then of 6 squared plus 4 squared. And if you work this out, you get the root of 36 plus 16, which is 52. And you can break out 52 as 4 times 13. This is the root of 4 times 13. You can square root 4, it's 2, and just leave it as root 13. So 2 root 13 meters per second. So that's shown that the magnitude of the acceleration of p is 2 root 13. Now, when it comes on to part B, we've now got to find the velocity of p at time t equals 2 seconds. And to do this, all we need to do is just remember that v equals u plus at. We can use this equation because we're dealing with constant acceleration. We know it's constant acceleration because we've got a constant value here. It doesn't depend on t, it doesn't change in any way. Okay, it's constant acceleration here. So therefore, if we change this to vector form, we've got v equals u plus a times the scalar t. And so therefore, when it comes to working out v will be equal to u. We're told that at time t equals 0, the velocity is this, so that will be the initial velocity. So that's going to be I plus 3j, and then it's plus t times the acceleration. T, we're told, is 2, so it's 2 times, and we've just worked out the acceleration vector. Here it was here, 6i minus 4j. So it's just a question of expanding the bracket and grouping up our terms. Our I components are going to be 6 times the 2 here is 12i, plus that I there is 13i, and then we've got 3j here minus 8j, so that's minus 5j. And there's our velocity. We don't need to find the magnitude, we're just asked for the vector quantity, velocity. So just put that as v there. All right.